Hello, today we're going to be talking to you guys about monoclonal antibodies. So what this video will cover is some background on what antibodies actually are, the mechanism of action of monoclonal antibodies, as well as some side effects and drug interactions. Antibodies are B-cell surface receptors that are often secreted. These antibodies are produced by the immune system in response to a specific antigen. These antigens are any foreign or unusual molecules which can be found on bacteria, viruses, toxins, and other foreign cells. We can engineer antibodies to target specific molecules or part of a cell, much like how antibodies target a specific antigen. These antibodies can be made with varying levels of mouse protein. Mouse, chimeric, and humanized antibodies contain some foreign proteins. Thus, the host immune response may mount an attack to target these proteins. This immune response can result in an allergic reaction. Here, we're going to look at some of the main mechanisms by which monoclonal antibodies actually exert their effects. The first of these is receptor blockade. So here we see a cell in blue. Now this cell could be any cell such as B cells, T cells, or any other cell really. Here we see the receptor and the respective ligand. The ligand is free to bind to the receptor and then activate the cell. Receptor blockade involves blocking receptors. So here we see a receptor in which a monoclonal antibody specifically binds to. This inhibits the binding of a ligand, thus prevents the cell from carrying out its normal function. An example of this is tocilizumab, which binds interleukin-6 receptor and downregulates its response, preventing inflammation. Thus, it is often used in the treatment of arthritis. Another similar mode of action is ligand blockade. So again here, we see the free ligands able to bind and activate the cell. Using monoclonal antibodies specific for the ligands, most of the ligands are actually mopped up. This prevents the ligands from binding to the receptor and exerting their respective actions. An example of this is adalimumab, which binds to tumor necrosis factor alpha and depletes the cytokine. This reduces inflammation and slows the progression of inflammatory conditions. Now, obviously by blocking inflammatory mediators such as interleukin-6 and tumor necrosis factor alpha, there is going to be a downregulation in the immune response. Therefore, individuals are more prone to infection. A serious concern while taking tocilizumab and adalimumab is increased risk of developing tuberculosis. Depletion is another mechanism for targeting disease. Here we have cell surface proteins. Antibodies come along and tag these cells, and this allows for further binding by cytotoxic T cells. This ultimately results in cell death. This mechanism of action is particularly effective in the treatment of cancer. Rituximab can treat B-cell lymphoma where there is sustained cancerous growth of B cells. Rituximab targets CD20 proteins on B cells and enables the destruction of cancerous B cells. Side effects of this, however, is that most other B cells in the body are tagged for destruction. This approach vastly hinders the humoral immune response and makes patients at risk to infection. Receptor downregulation is yet another use of monoclonal antibodies. Here you can see the free receptor which antibodies bind specifically to. This in turn results in the receptor being taken into the cell, thus reducing the number of receptors. This ultimately reduces cell signaling dependent upon that receptor type. Omalizumab is a receptor downregulator and works as an anti-IgE. By reducing IgE, there is a reduction in inflammation and is used in the treatment of allergic asthma. However, IgE has been shown to be protective against some cancers. This downregulation in IgE has been predicted to be a potential cause of the development of cancer. IgE is also very important for recognizing helminths. Thus, there is a greater chance for infection by helminths. Finally, induction of signaling is a useful mechanism by which monoclonal antibodies can act. Binding to the receptor induces receptor-mediated signaling within the cell to change the cell's behavior. Side effects of using signaling-inducing antibodies include cytokine storms due to a release of too many cytokines, as well as autoimmunity as a result of heightened immunity. Monoclonal antibodies have no direct interactions with other drugs or small molecules. This is because the clearance of antibodies follows a distinctively different path to the clearance of most drugs. However, monoclonal antibodies that target cytokines have been shown to affect CYP450. Therefore, these antibodies may indirectly affect the metabolism of a number of other drugs.